Okay. Welcome, everyone. For those who don't know me, I'm Shah. This is the Data Entrepreneurs. And today I'm super excited because I'm joined by Paul, and he's going to be talking about something that a lot of entrepreneurs are very much interested in these days, which is building systems with LLMs. And so Paul's actually done another workshop with us. And last time he did a workshop with us, he kind of broke our streaming system and the way we host events. And I'm happy to say that he's done that yet again. We were originally going to do this event on Google Meet, but we kind of destroyed the 100-person limit that we can have in a Google Meet call. So that's the reason why we're streaming live on YouTube and LinkedIn. So I don't want to hold up the talk, so I'll just hand it over to you, Paul, and then we can get into it.
Yeah, hello everyone. I'm excited to be here. So as Show said, today I will dig into a presentation based on my latest book, which will show you at a very high level overview what it takes to take an LLM to production, how to build an LLM system, how to design it, some challenges and everything around it. So yeah, let's dig into it. So first, let me tell you a few words about myself. So I'm from Romania. Maybe it's well known as the land of vampires and good internet. It's already night in here, but I promise that I will behave. I have 7+ years of experience in AI, ML, MLOps, of however you want to call it. And I'm doing content on LLMs, MLOps, and RAGs soon. I will add this on top of my content soon for the latest like 2 years or so. You can find me on LinkedIn where I post daily and on my Decoding ML ecosystem. Links, I will attach links at the end. And also I started doing consulting in the LLM and LLM Ops space in the past months and everything was great. So yeah, let's dig into it. So as I said, this presentation will be based on my latest LLM Engineer's Handbook, which I released like 1 month ago or so. I'm one of the co-authors together with Maxime Lebon, and it was actually endorsed by the CTO of Hugging Face and the CTO of ZenML. And throughout the book, we show you how to build one big project instead of multiple smaller ones, because we thought that by doing so, we can really highlight what it takes to take a proof of concept, which is similar to what you will do doing your job in, yeah, and really tackle all the aspects it takes. And we cover things such as custom data collection, not using static data sets, which is really easy to work with, and you use that just in toy projects, RAG, LLM fine-tuning, LLM optimization, LLM ops, and more. So yeah, now let's start and dig into the technicals, right? So let's first understand the LLM Twins architecture. So first, let's understand what we think about what is an LLM twin, right? So it's a term that I coined, and it's actually an LLM where you want to inject your style and voice. And more specifically, for this use case, is an LLM where you inject your style and voice to write posts and blog posts like yourself. So no, I'm not doing this yet. I think it's still like a proof of concept, but at some point when this technology will mature, for sure, we will be able to do that while really being good content, right? So you can, of course, do that, but usually that content is trash or very neutral, not engaging, and all of that. So yeah, let's dig into the technicals, as I said. So the high-level architecture is split in the data collection pipeline, which takes in raw data, right? Takes in raw data, processes it, and puts it in a data warehouse. Next, we move to the feature pipeline that takes this raw data from the data warehouse and and processes it to create fine-tuning data and RAG data, right? Because usually in an LLM system, you need data for two things: for fine-tuning your LLM and for RAG. We take this raw data from a MySQL DB data warehouse. We will highlight this a little bit later. As I said, processes it. In our particular case, we have three types of data: articles, posts, and code. Processes it and put it into a logical feature store. Why in our case is a logical feature store and not just a feature store? Because we are kind of creating what a feature store should have out of a vector DB and a data registry, right? So there are other technologies like Hopworks and Tecton that are feature stores and offer this off the shelf. But I think that in the LLM world, at least at this point, you don't really have everything you need in these technologies. Probably in a few months or even earlier we will, but when we did the course, we haven't. Okay, then on the training pipeline, we take the fine-tuning data from the logical feature store, train the model using various techniques, which we'll attack later, and the output is a fine-tuned LLM, which will store in the model registry. And the last step is the inference pipeline, which in our case is actually a chatbot. So this is a really high-level overview of what's going on. I would start zooming into each component. So that's why I went really fast over everything, because now we are digging into the details of each. So yeah, so let's dig into the data collection pipeline, which looks like this. As I said, we will mostly crawl three types of data categories: articles, repositories, and social media posts. For example, articles we can take from Medium, Substack, or custom blog posts. Repositories from GitHub, or other Git-like repositories, and social media posts, LinkedIn, in our use case, but you can extend it to X or Instagram or whatever, right? So we had to build like an ETL-like pipeline for each, because each source needs to be like crawled differently, because each site has like a different HTML structure that needs to be parsed, cleaned, structured, normalized, and all of that before stored into a NoSQL data warehouse. So we use the MongoDB NoSQL as a data warehouse to store our raw data. This is not like really the standard data warehouse that you see in books, because a data warehouse usually needs to be like to have analytics properties, like to be able to analyze your data, to compute all kinds of statistics. But usually these data warehouses are more heavy, and we don't use that in this book. So because of our data, which is very unstructured and text-like documents, using a NoSQL database allowed us to really easy spin up everything and store everything like in a production-like setup, because MongoDB can scale up really good and you can actually use this. And in some future steps, you could actually like take this data and put it in a real tool that offers you like analytics, like BigQuery or something like that, right? And while we are taking the data and storing it in raw format, this is actually really good practice, because storing your data in its raw format allows you to experiment, reiterate with the next part of your system. For example, if you want to change some part of your feature engineering or change some part of the system or add some extra stuff, you have all your raw data, which you have access to really easily, and you can recompute everything from scratch. because if you rely only on these ETL pipelines that crawl data and all of that, the internet is a moving system and you never guarantee that you have access to that data anymore, or at least in the same format. Okay, some tools to do crawling are like Selenium, if you want to go like how more low level and have a lot of control. Also HTTP requests, you can directly make GET requests on some pages and parse the HTML and it's good enough. You can parse this structure with Digital Soap. Also LangChain or Llama Index or these kind of tools offer some high level methods to crawl and get data from the internet. And Firecrawl, I used it in the past weeks and really liked it to crawl all kind of stuff. I think it's a really plug-in and play crawling tool that is really powerful. So yeah, so now let's move to the RAG part of the system. So let's move a little back. So after the data collection pipeline, we have the feature pipeline, right? Which is actually a RAG feature pipeline because here we want to prepare the data and load it into a vector DB for RAG, but also prepare it for fine tuning. And that's why I want first to really go really fast on what a RAG system looks like, right? So we have the RAG ingestion pipeline, which has the following components. You have the RAG ingestion pipeline, which actually consists this part where you need to clean, chunk, and embed your data. Many times it actually has the extract part where you need to take data from somewhere. But because we took the extraction part and reformulate it as a data collection pipeline, in our case, the extraction part is just reading from the data warehouse. So it's really easy. So here we focus on cleaning, chunking, and embedding. Next, actually, after embedding, we also want to load it into vector DB, right? Obviously. And the other part of the system is the retrieval and generation pipeline. These two parts actually run on different processes. So the RAG ingestion pipeline usually is like a batch pipeline or streaming pipeline that does these things constantly because you want to constantly grab data and update your vector DB. While the retrieval and generation pipeline usually runs when you need it. For example, when a user wants to do a query, right? So then you take your user query, embed it, call the vector DB to find relevant chunks and create the prompt based on the user query and chunks and generate the final answer. So this is like a very standard RAG system, and every RAG system has like these main components at its roots, right? For example, if you want to optimize a RAG system, which is also known as advanced RAG, you mainly have the few areas where you should look at when you want to optimize it. For example, at the pre-retrieval stage, which usually on the RAG ingestion pipeline consists of how you clean and how you chunk the data, which is very important. Many times are like the most important parts which you can optimize. Not the sexiest part, but the most sometimes are the parts that have the most impact. And also on the retrieval and generation part, the user query, the user input. For example, is it like verbose enough? Does it have grammatical errors? Do you need some specific entities to be in it? And the types of things that can really do magics in how you query the vector DB. Next, we can optimize the retrieval part. Again, on the RAG ingestion pipeline, we have, for example, what embedding model we use, right? And on the retrieval part, we could think about things on how we query the vector DB, for example, how we can reduce the search space to increase our probability of good hits in the vector DB. And the last part is the post-retrieval part, where after we retrieved our potentially relevant chunks, we want to reduce bias, reduce noise, and sometimes we don't want to have a huge context due to latency or cost issues. We want to reduce it and let only what's essential in it, right? And next, we pass that context to the LLM, and we are back to the standard pipe. Okay, so let's see how the RAG feature pipeline, aka the ingestion pipeline from the standard system, looks like. So in our LLM twin use case, right? So we always come back to our LLM twin use case. So as I said in the beginning, we consume raw data from the data warehouse, and we want to create two snapshots. The one is clean data, which will be used for fine tuning, and the other one is chunk and embedded data, which will be used for RAG in our particular use case. Because we wanted to keep it simple here, for example, for cleaning, we used a very sneaky but simple method where we just kept all ASCII characters, because we know that only ASCII characters can be thrown into the embedding model and processed. Okay, like if you want to create a real product, we want to be more careful about this, because sometimes italic, bold emojis can have a lot of signal in them, and you want to process them. And for chunking, we use like the standard, like where you look for paragraphs, and then based on paragraphs, just chunk them based on the context of the embedding model. Again, you can go really deep into how you do this and spend a lot of time on optimizing your chunking part, right? But we will dig more into advanced parts when we will look at our retrieval client, which is this one. So the clean data will basically, we will take the output of the clean model and throw it into the vector DB as is, because you can actually use the vector DB as a NoSQL database. Most vector DBs have support for querying just for IDs, and put any text into the metadata. And in the end, that's a NoSQL database. And then we do the standard chunking and embedding, and we put the vectors plus the metadata in the vector DB as usual. Okay, so now let's move on the other side of the spectrum, on the RAG inference pipeline. So this is where we put stuff into the vector DB, and here is where we query the vector DB. And here things looks a little bit more complicated or more interesting, depending how you want to see it, versus like the naive RAG system. So let's look how we can optimize like the pre-retrieval part of a stack, or how we optimize in our LLM system the pre-retrieval part of the system. So one quite easy method which you can adopt is query expansion, where you take your query from the user and use an LLM to find like different perspective of the same input, which will have like different words or a different meaning, or try like to see the truth from different angles. That's basically what it does. And the second method is to use self-query. This is really powerful when you have some entities in your database that you want to filter. For example, we use the author entity to filter down parts from the vector DB, where you take the author, and when you do a search, try to find context just based on that author. You can always extend this to more practical use cases like tags, which is a very standard use case, right? Or any entity that's used within your application can be used here. So again, you use an LLM to extract these entities, which we will use later in the retrieval part. Other options, as I said, that you can further optimize are like chunking, or just use an LLM to be ensure that the query is verbose enough, doesn't have grammatical errors. Even if when you embed it, it's not that is not the biggest mistake to have grammatical errors, but yeah, it's a thing that you can play around with. Now, on the retrieval part, we used a simple filter vector search that reduces our search space to only entities to only documents that we know we care about. So we reduce the chance to grab faulty chunks, faulty documents. Other things that you could think about is the hybrid search, especially in systems that still use keywords. So combining keywords with this semantic search are actually really powerful. You could also think about routing, right? So maybe you can optimize, you have multiple collections, and for specific queries, you think you care only about one or two collections, not about all of them. In our particular use case, we have the articles, repositories, and post collections, and maybe for some queries, we care about only about the articles, right? And in the post retrieval part, we use the classic re-rank, which is actually really powerful because systems are usually biased about the first part of the context and about the last part of the context. And also while using re-ranking, you can, for example, search at the retrieval part for a larger context window. So let's say 20 chunks, and using re-rank, you sort them and take only like the first 5. So like this, you also filter out the noise, filter out the bias, and also reduce your context with one algorithm, which is intuitive to understand and powerful. You instead of like using the standard re-ranking models, I've seen that it's quite popular to use another LLM as a re-ranker. I don't have a strong opinion on which one is better. It's, again, I think, a very experimental process. And yeah, so this is about the RAG inference pipeline. Now, so we have the RAG collection part, the RAG feature pipeline, and the RAG inference pipeline. Now, let's understand how we could like deploy these things. For example, the inference pipeline, which is actually like our chatbot in the end, right? So if you think about it, we have this query, all of these like advanced things are going around. Then you have the context, you create a prompt, you throw in this prompt to an LLM, which is like either an API like OpenAI or Claude or whatever, and get an answer, right? So now let's see how we can deploy all of this without using these APIs, like, as I said, OpenAI or Claude or whatever, right? So we have two parts. The LLM microservice, which is in most basic applications, is, as I said, replaced by these APIs. But in our particular use case, we wanted to build everything from scratch, so no APIs, right? So a standard approach is to use systems like SageMaker to deploy this, or Bedrock, or Modal, like serverless systems, or actually use like open source tools like text inference, text generation inference from Hugging Face or VLLM, like open source solutions, take them and put them on a Kubernetes system. So there are various approaches, but I think that in the beginning, I wouldn't go like on this open source route because it can get complicated. And I think the easiest way to do it is just choose Bedrock or Model or other serverless solution, build out your system, iterate fast, and then think about other optimizations. In the book, we picked SageMaker because it's like a very good middle ground between building things yourself and serverless, because serverless hides everything away. You just write a few lines of code and it works like magic. So because it's a book, we did not want that. So we choose SageMaker, which still you don't have to manage everything yourself, but you have some more control on what quantization method you pick. So you load, for example, LLM from Hugging Face from Hugging Face model registry. You can choose how to quantize it. You have control over the tokens, over the compute that you can run, and you can play around with all these parameters, which give you a sense of what it takes to have that LLM in production. But the end result is a REST API, similar to OpenAI, that you can query and play around with, right? And on the other side, you have the business microservice, which actually has all this advanced RAG logic, right? Usually you want to divide the LLM microservice and the business microservice into different services. Of course, this is not mandatory, but why personally I think this is useful? Because first of all, usually these LLM services don't give you a lot of stuff besides hosting your LLM. If you want to add some extra stuff, it gets quite complicated because you're really embedded into this LLM ecosystem. And the second part is that the LLM microservice is really GPU dependent, and usually the business microservice is CPU and IO dependent. So let's take this example. Usually an LLM takes in client requests, and directly takes them and processes them with the LLM, which directly puts that data on the GPU, processes it, gets a response, and sends it away. You can do some dynamic batching to process multiple requests at the same time and that kind of thing, but still it is GPU bounded. While the business microservice, where you have stuff like RAG or monitoring, you are mostly CPU and IO bounded because you take a client request, right? You do some API calls to other services, which are IO bounded. Then you do an API call to the vector DB, which is IO bounded. Then you, I don't know, aggregate the data, do some string concatenations and that kind of stuff, which is CPU bounded. So you don't really depend about models here. It's mostly like a standard service of like a Python server that we are used from the software engineering world, right? And yeah, and because you decouple them, you can also scale them differently, like horizontal scaling. And yeah, you have more control on how we can do this. And also, one thing that I missed is that you can take this business microservice, and also here is where you hook the prompt monitoring pipeline, where you take your prompt, which you compute here, and you get the answer from them in microservice, and you send the whole chain to the prompt monitoring pipeline service, or however you want to call it. And you can see this as the business microservice, the place that aggregates your business logic. That's why it is called like this. So as I said, you have your RAG, prompt monitoring, and in the end, you can expose it as a REST API using frameworks like Fast API, but you're not bounded to do this. You can expose it as gRPC or directly put it maybe on a client application or whatever makes sense for you and your application. Now, here we deployed only the inference pipeline, the chatbot, right? The final product that you interact with as a user. But what's left is to look at how we deploy all the ML pipelines, right? So we have that data collection pipeline, we had a feature pipeline, we had a training pipeline, how we deploy them, right? Because usually people stop here and leave the other pipelines untouched, and usually they run them manually and take the model from the model registry, and everything that's before the model registry is a mess, and it is hard to reproduce. So For example, a really good strategy is right to start with versioning your code, right? Having all your code in GitHub. Then when it comes to code, it's actually like the standard software engineering pipeline that you want to take it and deploy it, which is, for example, in our book, we use ZenML to orchestrate all our pipelines. So they provided this option to have it in a ZenML code repository. Then out of this, we Dockerize all our code, put it in an ECR, Docker registry, which is AWS version of a Docker registry. From here, we can take the code packed with all the dependencies, system dependencies, Python dependencies, and everything we need in a Docker container. And ZenML let us to take these Docker containers and ship them to SageMaker, which was the compute, right? So basically, we have all the pipelines packed in a Docker container, and we told ZenML that, hey, here is our Docker container with our ML pipelines, and we want you to put them on SageMaker. Using ZenML, you can do this through the UI, or you can even automate it further using infrastructure as code, like Terraform, or that's it from my knowledge. But I know they add tons of feature in this MLOps zone. So this is the code. This is the compute. And again, using ZenML, we actually hooked to S3 as artifact storage. And we independently wrote custom code to connect to Quadrant and MongoDB. Quadrant as our vector DB and MongoDB as our data warehouse. So now we have the code packed as a Docker container, put on SageMaker, everything runs perfectly. We can scale this easily, like each pipeline can be scaled independently on different EC2 VMs on AWS and all of that. We have the S3 storage as blob storage, where you can put in files, images, and everything you think about, as long as they're not tables. And we have Quadrant and MongoDB, right, or as storage. And how we can execute these things. So everything is waiting for us to be executed. Through ZenML, we have different options. So the most obvious one is the ZenML dashboard, where you just go in there and with a few clicks, you choose what pipeline to run. You can do it through the CLI, which this offers you tons of other integrations, or a pipeline can be triggered by other pipeline or event. For example, in our use case, we had a data collection pipeline, which after event, it triggers the next pipeline and so on and so forth, which I will detail a little bit later on how you can do continuous training with this trick quite easily. As I said, for storage, we have these three guys. For compute, we have SageMaker. And for triggers, we have the dashboard, the CLI, or other events. And sorry, Quadrant, that I wrote your name, that I typoed your name. Okay, so the last part of the system is MLOps, right? As I said, how you can actually automate this part. So far, we have the data, how we gather data, how we train. I know I haven't touched the training part, but that's part of Maxime part of the book. And I don't have the visuals for that, and I did not wanted to use the visuals for that. But I will touch the training pipeline like an abstraction. And from the MLOps point of view, it's enough. So yeah, how we have all these pipelines that creates our model, which is in our model registry, that creates our features and training data, which is in our logical feature store. How we can take this and operationalize it, like do the ops part of things. For example, when you change the code, how you can reflect all these changes into your production system. So that's actually what MLOps is all about, but not only about the code, also about the model. If the data changes and you want to create a new model, how you can do this automatically without going to your computer and running 10 scripts manually and not being sure what's going. Okay, so the first part is to build a CI and CD pipeline. So again, this is actually classic software engineering and DevOps. A CI CD usually checks. So a standard process is that you work with GitHub or similar solution and you have the main branch and you create a feature branch, or you can also have a staging environment, and you can make this more complicated, but for the sake of this example, we have production and feature branch, right? So when you work on your feature branch and you want to do a merge on your production branch. To do that, you actually first create a pull request, which will trigger automatically linting, formatting, and testing. Linting and formatting usually test your code, how you format your code, or linting can actually check for check for bugs, which can be detected at the syntax level. Formatting checks for how you write your code, and testing, these are like your unit integration system tests that you have to write and check that your code works well. If all this passes, you can merge your GitHub branch into main, and the continuous deployment pipeline triggers, which works as we spoke before. We have the ZenML code where we build a Docker image out of it. We put it in an ECR Docker registry. And for this is enough, because here we have two options. Either we decide to trigger the pipelines manually, but this time we do it from the ZenML dashboard. So with one click, we can trigger our whole system, or we can put in our CI, in our continuous deployment pipeline, another trigger to actually trigger our pipelines automatically, pull in the latest part of the data, trigger all our ML pipelines, create a new model, and take that model and push it to production, right? So if you are here, actually, it's quite easy to move forward. Next, on the continuous training. So this is actually the other part of the system where we want to do continuous training, which means that basically with one click or on a schedule or to a REST API trigger or whatever your trigger is, you want to create your next production model candidate in one move. So with ZenML or other orchestrator, this is actually quite easy. Maybe it sounds daunting, but it's quite straightforward, right? So you have the trigger that starts your data collection pipeline. Then your data collection pipeline moves your data into MongoDB. And because we detached all these components through data warehouses, feature stores, vector DBs, model registries, artifact stores, and every component has a clear interface and is not coupled to each other in the code, it's easy just because at the next step, we trigger it. For example, so because we are using an orchestrator, this pipeline can, for example, the data collection pipeline can trigger the next one as the RAG feature pipeline, which will know to take the latest part of the raw data from MongoDB, or we could even version it and tell it that, hey, I want a specific version from MongoDB to take it and create features out of it. Then this feature pipeline will create another trigger for example, to trigger the generate instruct data set pipeline, which we haven't talked in this presentation because I have only 45 minutes and I can't touch everything, but you get the idea. So if you create your pipelines modular and you detach them through all these elements, then basically you just create a DAG, which is a sequence of components that are ran sequentially, and each one triggers the next one. And the output, the final output are the LLM weights, which are stored in the model registry. And here on the deployment part, where you want to take the model and deploy it to production, you can adopt various strategies like check if the new model, the evaluation metrics are better than from the previous model. Then you can adopt like techniques like A/B testing or canary testing and all of this before actually pushing your model to production. And this depends on the maturity of your system usually. And I think that one thing that I want to touch, because I see that I have 2 more minutes before the Q&A, and I forgot to highlight, is actually it's at the beginning of the presentation, but I think that I will stick to this one, is that for MLOps, if you are just at the beginning, what you have to understand are that you need to use a feature store and a model registry under one form or another. So the model registry never helps you not to store your models on your disk, on your GitHub, or whatever. You always store your models in the model registry where the models are versioned, tracked, and can easily be shareable with everyone from your team, from your company, or publicly, right? And with a feature store, again, a feature store, like one of the main features is that it has a data registry, which we labeled it here as a logical feature store because we built this data registry actually with ZML artifacts, which were backed by S3 artifacts. So with the data registry, similar to a model registry, you can store your data, version your data, share your data, and with all the perks that come out of it. So by using these two, you can easily have lineage, and you can always understand that a model was created with that version of the data. If you use GitHub, was created with that version of the code, and you can easily add through the meta store to also track your configuration and other things. And again, we label this as a logical feature store because along with this data registry, we also needed the vector DB features for RAG. So and another thing that you need for production is to have 2 types of data access. One is offline, which is usually optimized for training, which in our case was the S3 artifact store, where we can easily store tons of data and access it in batch mode. And the other one is like an online store, which is optimized for low latency, which in our case is the quadrant vector DB, where we need usually we request for 1 item, but we need it really fast, as fast as possible. So to go to production, you need these 4 elements ASAP: a model registry, a data registry, an online store, and an offline store, right? So these are like things that you really need to consider when you design a system. So I think that's it. I think I'm in time. So you can find more on my socials, or I like LinkedIn, on my Decoding ML newsletter, which is also a blog now, where I talk in depth every week about these type of things, like around LLMs, MLOps, LLMOps, and recommender systems, and more on my book. So if you enjoy this, in our book, we go a lot more in depth, and also on the fine-tuning parts of the system. As I said, supervised fine-tuning, preference alignment, LLM optimization, quantization, how to generate a custom instruction data set, a preference alignment data set, and all these stuffs around fine-tuning. And you can buy it on Amazon, also on tech sites. And you can, the repository is open source, and you can play around with all of this if you don't want to buy the book. The README is quite comprehensive, and we try to make it as an independent experience. And also we have the LLM Twin course, which is like inspired by this book, and it's like, I don't know, 20% of the experience of the book, where we touch again parts of what I've talked about today. So yeah, I guess it's Q&A time.
Well, let's thank Paul for a wonderful presentation. I always learn so much whenever you come give a workshop. So let's do the Q&A. So for this, I'm gonna move some things around. So we got a bunch of questions in the chat, so I think we can just like dive right into it. Let's see. Actually, I think Jorge was first. Okay, so Jorge asks, what are your thoughts about using Graph RAG or Agentic RAG in this use case? How do you know what RAG method is the best used?
From my experience, Graph RAG sounds really promising. I'll be honest, I don't have yet a tons of experience. I started reading into it, and it sounds amazing. But one problem that I've seen with it is that usually it adds a lot of complexity and latency issues. So my approach would be usually to create a first iteration of the system as naive as possible and focus a lot on the evaluation of the system. So it's really important to quantize the results and expectations of your system. Then, if you understand what you expect from that, you can start thinking about optimizing. Because if you don't know what you optimize, you actually just follow the hype at what you think is more interesting and cool. So yeah, that will be my approach.
Yeah, just start as simple as possible, get the system actually working, and then you can worry about doing more sophisticated techniques. Good question.
Yeah,
we
yeah,
got
exactly.
Oh, go ahead, sorry.
Yeah, go to the next one.
Yeah, we got a lot of questions, so let's keep it rolling. Anius asked, Is there a real use case for RAG and LLM engineering for individuals, or is it primarily centered toward B2B? So I guess maybe like ICs.
The question
like
you interrupted for a second.
Yeah. So I guess the question's like for individual contributors or, just people working on their own locally, are there like good use cases for RAG and LLM engineering? Like, what do you think?
Oh, yeah. Yeah, totally. So, well, I think that one amazing use case is the LLM Twin, where if you're in content creation and it's not necessarily business to business, it has tons of value. Another use case is research. If, for example, if you want to find any kind of information, right, you just throw in a lot of documents and you start talking to these documents. I think this is, from my experience, this is the most exciting part of it. And actually, there are like open source tools that you don't need to build this kind of stuff. They're like have a pretty UI. They let you throw in some documents and chat with them.
Yeah, another one could be
I don't know
if you want to read the LLM Engineer's Handbook, but you don't want to read the whole textbook, you can just throw it into one of these RAG systems, and then you can just chat with it and have like a Paul and Maxime guiding you through your development, like your use case.
Yeah, exactly. And here you can have like two options. Like one is to create an overview of the system, like what I've created now for you guys, because maybe in the beginning you don't know what questions to ask, so you just want to explore it, and based on that you can start asking questions and dig into what you think is more interesting.
Yeah, that's good. Let's see. We got another one from Miguel who asked, I'm trying to implement an ETL pipeline for job matching. Any ideas or suggestions on how to tackle this?
I personally think that here, this is more like a recommender system problem-ish. So you have like a user and a company, and you want to see which has a higher matching score with the other. So I've actually seen and playing around with this using LLMs as ranking systems. And in recommender systems, most of them are split into two parts, like the retrieval part, where you, for a user, you want to grab some candidates, which is more coarse. And then you have like this ranking step where you want to filter out and remain only with what's more important, and which is really similar to a RAG system in the end. And I think that you can use like this ranking part. For example, if you want to do it just for yourself and you already have the candidates, you can dig into some how to use LLMs for ranking in recommender systems to find out more ideas on how to approach this.
Yeah, that's cool. Good question. We got another one from LID. I think I butchered that, so I apologize. But the question is, how do you choose the right chunking strategy for your LLM application? I think it's a very big question right here.
The right chunking strategy.
Yeah, that's right. For your LLM
Okay.
application.
Okay. Yeah, this is a hard question personally. I think it's really dependent on your data. So, because by having domain knowledge, you know how it makes more sense to chunk your data, right? So, okay, of course, I can tell you like the standard. Okay, you can take a document and look at like uh, sections and split it by chapters, split it by subchapters, by sections, even take around tables, images, and all of these areas, go even down in paragraphs, sentences, and all of that. Of course, that's important to consider. Other options are like semantic chunking, which kind of looks at parts that are correlated with each other, or but if you not have the domain knowledge, like if it's financial or I don't know, medical of all of this, I think you have a much better intuition on how to pick these delimiters than just trying to generalize it. So yeah, other options are like this graph RAG like systems where you try to keep the relationships between the chapter, the section, and all of this, right? So you kind of keep this narrowing down relationship. And when you find a part of a paragraph or a paragraph, you can grab the context of the bigger part of the system. Or there's also this context RAG implemented by Anthropic or something like that, which creates this context and adds it directly to the chunk. Also, yeah, this is more an art than a straight answer, I guess. So
Yeah, they're
this is why
endless.
it's so vague usually.
Yeah, endless approaches and strategies, and it sounds like very much dependent on the specific use case. Let's see. We got
Yeah,
another.
exactly. So it's really hard to.
Yeah, hard to give a broad brush answer, a general answer to the question. So we got another one from Jorge. What methods, frameworks are you using to evaluate the LLM twins outputs?
So what methods and frameworks? So this was done actually by Maxime in our specific book, and we haven't used any frameworks, which many times is fine, I think. So we actually use an LLM as a judge. So when it comes to evaluating LLMs, you kind of have like uh two big options. One is using heuristics, actually three big options. One is using heuristics, which if you can't extract the output of an LLM in a very structured and deterministic way, it's not a good metric. For example, you use an LLM for classification or text extraction, entity extraction, then you kind of know what to expect. So the answers are black and white. In this case, you can use like classic heuristics. They're perfectly fine. But if you move away into a more like generation space where two pieces of text are both correct but just formulated differently, here usually you can have two options. One is like, are these embedding based scores, which I think they're called like semantic metrics, where basically you embed the ground truth and your answer and use this cause distances or others to see the difference, semantic difference. And the third option is using LLM as a judge. When you are thinking about LLM as a judge, the nice thing about it is that you can also have a ground truth where you put an LLM to compare the two, but you can also do not have a ground truth and where you can ask an LLM for more to dig into the text for specifics. Like for example, in our LLM Twin course, we created a custom style metric, right? Where we asked the LLM, we created multiple scores from 1 to 5, I recall, where we asked him, hey, if the text is super general and contains super complicated words and it's not like a blog post like, then give it like a score of 1. And as it goes more toward expected value, give it a score of 5, which was the highest. And there you don't need a ground truth, you just need to explain like for each threshold what you expect from the output, which I think it's really powerful because many times you don't have ground truth. This is like a big problem in AI before. So LMS judges are super handy in this case.
Yeah, for sure. Eval's a huge space, but I guess we're lucky in that we can use other LLMs to evaluate our LLM systems. We're running
Yeah,
short on
yeah,
time, but
and
oh, sorry, go ahead.
yeah, one last thing is you can use tools like Opic, which actually have these prompts very well tested to use LLM as strategy. So they come with out of the box well tested prompts to test them for various scenarios.
Okay, yeah, that's
And
a good
that's it.
call out. So I do want to take two more questions, and then we'll wrap up. We'll go a little bit over, so we won't get offended if you have to drop. But I just want to get at least two more questions in. So let's see.
No,
Must
it's fine. I mean,
Okay, cool. So must exist asks, let's see. You talk about feature store and continuous training. How do you think about these for large language models? What are features? How can we train them?
well, yeah, you got it right. So when it comes to NLP and large language model, I think that the term feature is a little bit like in a gray area. So usually a feature is what you feed directly to a model. But in our use case, usually you take the text, tokenize it, and put the tokens into a model. So if you go by the book, the features are actually the tokens, like those IDs of the tokens that you feed into a model, and then you have embeddings associated with them that go into the transformer architecture. But I think that it's easier to think a little bit higher level and consider the text as a feature. I think just at a human level, it's more intuitive to see it that way, because usually you take the tokenizer, which is model dependent, and attach it to the model. So like this, the features are more independent to the model, so you can take the text and apply which are stored version and all of that into the feature store, and you can take the tokenizer plus different tokenizers with their models and try different experiments. So I think it's more intuitive and more flexible to do it this way. I hope
that's good.
Respond to your question.
It's interesting as machine learning evolves. I guess our terminology and like what we call our technologies may have to evolve as well. So let's do this last question.
Yeah, it's really hard to go by. It's really hard to go by the book sometimes. Maybe that will annoy some people, but yeah.
So let's do this one last question. And I think it's a good one. So it's on security. So for context, Steve was asking about the testing for vulnerabilities as outlined by OWASP AI Exchange. So he asked, could you elaborate on how security testing is integrated into the pipeline on different deploy environments, or is it managed separately?
Yeah, I will be honest with you. Like, security is my Achilles point. So I don't really know. Usually on this security stuff, I don't know. It's not. I usually pass this stuff to other people because
you give it to the other guy. So let's do another question then. So we got one more from Basel. What's your preferred observability platform for reinforcement learning fine tuning? Or I guess maybe just fine tuning in general.
Yeah, so I think that fine tuning and observability are like two different concepts, where with reinforcement learning with human feedback can have some connections with each other. But for example, again, I played a lot with Opic in the past months, and for example, Opic lets you like gather your feedback scores from why you're monitoring your inference pipeline, right? So with an observability platform or tool, you gather these scores and aggregate them into a future data set. So that's what you're doing at the observability step. But while you're fine-tuning, you actually need an experiment tracker. For example, Comet ML, weights and biases, ML Flow, Neptune. And that's where you take the data you created with an observability tool, take a version of it, and fine-tune your model and track your metrics like loss or other evaluation metrics you need during training.
Yeah,
well, that's how I would do it.
Yeah, I think those observability platforms you mentioned are super helpful, like weights and biases and all the countless others that are out there. It's super cool that, MLOps is, you don't have to code everything from scratch anymore. You can use these ready to go platforms.
Yeah. Otherwise, it would be a nightmare. Okay. Still be using Matplotlib.
Exactly. So let's wrap up. We went a little bit over. I dropped Paul's socials in the chat, so I'm sure you can reach out to him if you have any questions that we weren't able to answer here. I just want to thank Paul again for such a wonderful workshop. Thank you guys in the audience for participating. You'll receive a follow-up email that kind of with the recording of this event, and then you'll get a link to all the upcoming events we have with the data entrepreneurs. So with that, thanks again, and we'll see you in the next one. Take care.
Yeah. Thank you for having me here. Bye.
Thanks, Paul.